Welcome to the third module of our AI Agents Bootcamp. In this segment, we will explore context engineering and memory, specifically focusing on how agents remember information and maintain long-term state across sessions. In this module, we will learn to differentiate between memory tiers, understand the impact of context on operational stability, examine state management in systems like RankPilot, and design robust memory systems including database schemas and conflict strategies. Session 5 of this module focuses on memory types, contrasting short-term and long-term memory. We will investigate context windows, database boundaries, and how operational session lifecycles work in practice. Without memory, agents suffer from structural amnesia once an API session closes, preventing them from comparing trends or tracking adjustments over time. Building persistent memory is essential for real business value and long-term performance. Here is our memory classification matrix. Short-term memory is ephemeral, held in RAM for active reasoning within a single chat session. Conversely, long-term memory consists of structured, persistent records saved in system databases to track metrics and preferences over time. This diagram illustrates the RankPilot memory interaction. It begins with a user request, followed by a session boot that loads profile data, execution of the task, persistence of records to the database, and finally a flush that wipes the short-term RAM. Moving into session 6, we will look at designing robust memory systems. This includes configuring proper database structures, implementing time series decay maps, and establishing custom strategies for conflict resolution. We categorize memory into 4 core layers. These range from the stable, long-term user profile down to the short-term system cache, with audit histories and session states filling the middle tiers. Managing memory decay is crucial. RankPilot uses time-based rules. Fresh data is prioritized, aging data may trigger updates, and stale entries are archived to maintain long-term trend lines. When conflicts arise, we use 3 primary patterns: relying on timestamps for the most recent data, cross-referencing against third-party fallbacks, or escalating contradictions to an orchestrator for developer review. Security is paramount. Persistent caches hold sensitive information, so we mandate database cryptography for data at rest and in motion, and enforce node-level boundaries to ensure agents operate under least privilege policies. For our design exercise, consider a financial coach AI for savers. You will need to map its schema boundaries, including goal tracking and telemetry data, and define your structural memory approach regarding tiers, conflict management, and data decay. To conclude this module, here is an evaluation quiz to test your understanding of memory tiers, strategic advantages of historical data, and the correct memory layer assignment for specific agent tasks. This video utilized images from stock photography and vector resource providers as cited here.